Are you ready to perform some more college football analysis in Excel? Hi, I'm Brian Amrine with Value Driven Analytics, and in this video, we'll pick off from where we left off in part one and perform some additional analysis, ultimately looking at the likelihood of a home team to win a college football game based on their previous performance compared to the team that they're playing in their previous performance. Along the way, we'll learn about how you can use pivot tables in Excel to aggregate your data, and how you can use functions like XLOOKUP to merge data from worksheet to worksheet in Excel. We'll look at how you can refresh those pivot tables with new data, and also how you can nest if statements to create a new column that essentially creates a grouping of a continuous variable. We'll do much more Excel data manipulation as well. If that sounds good to you, let's head over to Excel. Now the next thing we need to do, this is a very granular table. It has now it has about 70,000 rows because it has games from both the home team's perspective and the away team's perspective. We need to now group by the team field, and now that we've done that in this comprehensive away and home team game data set, when we group by team, we'll have all of that team's history for that season represented. But before we even aggregate, we're going to need to create another field here that is the team season combination. Initially, I would think, well, I need to group by team and then bring that into our postseason games. But a team in one year can be quite different from the team in the next year. So really what we want to do is bring in that team's history for that particular year. So we're going to create a field in Excel. Oftentimes you have to kind of create a field that is the combination of all the fields that you want to join on. And in this case, we want to join on not just team, but also the season as well. So we'll call this team season, and it'll be based on a formula. This is an interesting formula. Now in this case, we're going to deal not with quantitative fields, but with qualitative fields, character fields. It's important to understand the data type you're dealing with. So in this case, we're going to deal with some character or qualitative fields. We're still going to use the equal sign. We're going to point to the team. This field will represent the team, and then we want that to maybe we'll use a hyphen to separate that from the season. So I'm going to concatenate by using the and sign, and that just tells Excel that we're about to give you another character. We want you to combine it with the previous character, the team, and combine, and then we'll put this in quotes. So double quotes, dash, double quotes, and then we're going to concatenate to that the season. And I'll press enter. That looks good. Okay, we've got the team, dash, and then the regular the season, all put together. Go to the bottom right here, double click to scroll that all the way down. Looking good. So now we have our team season, and at this point I think we're ready to go ahead and do some aggregation. Now there's probably a few ways of doing aggregation in Excel, but a very common way, you will do well to learn this feature. It is very popular, but yet some people that use Excel do not know about it. So you're about to learn about it, which is great. What I'd like for you to do is click on the top left of our RS Games worksheet. Let's select all the data. Essentially, we want you to select the data what we're about to do is going to be based on, and we're going to go to the Insert tab, say Pivot Table. All right, you can say this is the range of data. It's all rows essentially from columns A through H. Where do you want it? We'll put our pivot table in a new worksheet. That's fine. Just click OK. All right, and we have a pivot table here. Perfect. It just gives it a default name of sheet 7. We'll call this winning percentage by team. It's really by team and season, I guess, by team season. All right, great. Well, we've got this table over here, we've got fields here, and we have some different places that we can drag those fields to. In this case, we are going to be using the rows feature, and we want our table to be one row per team season combination, and that's why we created that field team season. So I'm going to just go ahead and drag that to rows. Great, look at that. All right, so we've got each team, we've got their team dash season represented here. Perfect. All right, now we're going to want to bring in our won variable. So here it is right here. That is going to go in the values place. So this is a quantitative field, a 1 or a 0. Let's see what happens by default when we drop it here. It wants to sum it up. It wants to tell us here's how many times that team had a win in that particular season. Well, each team usually plays about the same number of games, but they could have played a different number of games in the regular season. And so we don't want to look at it from a sum perspective. We want to look at it from an average perspective. And remember, because this is a binary indicator variable, it's a 1 if they won, a 0 if not, taking the average is a way that we can just calculate what percentage of the time did they win. I suppose another way of calculating that would be to do the sum of how many times they won divided by the total number of games. But doing the average of a binary 1-0 variable is a much quicker way of doing that. So that's what we'll do here. If we want to change the function being applied to that quantitative variable, we can just simply click on value field settings and say average. There we go. All right, we've got as a decimal here. I'll go ahead and click on the whole column, right click, format, so we can change the format for everything. We want this to be as a percentage. I'll do 2 decimals is fine for now. There we go. All right. So we see each team's winning percentage in that particular year. Really interesting. Now we can highlight this and we can well, it looks like we only have a few summary statistics by default here. I'm going to right click here, and I believe we have the ability to add some other things like minimum, like maximum. So there was some teams, unfortunately, they lost all their games that season, and there were other teams that, yeah, sometimes win all their games. You have a pretty good variety there. Well, that's our winning percentage. Now, I think we're ready to come back, and what we want to do is bring this winning percentage into our postseason games. We want to add that as an attribute to this table. Okay, we just did some aggregation when we used that pivot table, and that is an extremely common and important technique. We talked about it in the Introduction to Analytics session of the series. Now we're about to do another really important type of manipulation, and that is take data from one data table and bring it into another data table. Sometimes we call that merging or joining. Whatever you want to call it, we're about to do that now. We need to do it because we need to get the winning percentage, the regular season winning percentage for the home team, for the away team, into this postseason games table so we can use that as an attribute to analyze. Now, in order to, whether you're dealing with SQL or Python or Excel, you've got to tell the system what to join the two tables on. And remember, in our case, we don't want to just join on team, but we want to look at, for that team in that season, what was their regular season winning percentage. And we need to code it in the same formatting that we used when we created our pivot table, the source that we're about to join to. So to start off with, we need to create the home team season variable, and we've got to code it exactly the same way we did before in order for it to be consistent. If we decided to put the season first and then a dash or another character and then the team, there would not be a match. They would be formatted differently. So we need to be sure that we say, okay, start with the team exactly like we did before, and sign, double quote, dash, double quote, and sign, concatenating to the season. That is the format we used before. We need to make sure we keep that consistent. So I'm going to just code that out, write the formula. I'm going to double click the bottom right corner here to drag it down. I'm going to double click the right edge of column K to expand it. And there we go. We've got the thing that we need to match on. Again, look at our winning percentage by team season. That's the format that it's in. It's team dash season. All right, this is where the joining is. Watch this. This is exciting. The variable that we're about to bring in, we need to give it an intuitive name. Let's call it home team winning percentage, and it's our regular season. I'll abbreviate RS for regular season. Home team RS winning percentage. I think that's probably a good name for it. We've already calculated that. It's in our pivot table tab, our winning percentage by team season worksheet. We just need to bring it into the workbook. Now there's a few ways of doing that to bring it into this tab. You can use a VLOOKUP. In certain cases, if you're looking it up from a horizontal perspective, you could use an HLOOKUP. In our case, and this works for vertical or horizontal lookups, we're going to use a relatively new feature in Excel called the XLOOKUP function. It starts with an equal sign, like all functions do. XLOOKUP. And what you'll see here is a little bit of guidance around what each function should represent. So the first one is our lookup value. And it's the lookup value for this particular worksheet, and that would simply be K2 for this particular row. We want you to look up Marshall 1998. Great. Next question, next argument, and all arguments are always separated by commas. Where do you want us to look that up? Okay, I want you to look it up over on this tab, and I'm going to highlight column A. Column A is where I want you to look up that value. Great. Comma. Next argument is, what do you want us to return if we find that? Well, I want you to return column B, essentially. So I'm going to see if I can get, well, I'm just going to copy this. I would like to just select, it looks like I can. It's right behind this guidance here. All right, I'm going to double click back in here. Okay, where do we want to return? What do we want to return? It is this same worksheet, but in this case we would want it to return column B. And then from there, there are a few optional things, I believe. This, if not found, usually you want to set that to false, which kind of tells it, I think, not to guess or look at the closest match. I almost pretty much always use false there. And then I'm not worried about the other. There are some advanced features that you could use as well if you need a more advanced kind of join. But in this case, this should work just fine. I'm going to use the close parentheses. Look at that. Look at that. Home team is Marshall, and it's 1998, and it returns 0.90, which would be about a 91% winning percentage for Marshall in 1998. Now let's test this. Make sure it worked. I'm going to grab this value, Marshall 1998, and go back to the winning percentage by team season where we looked it up. Again, we return column B, which has our winning percentage for that team season combination. I'll do Control F. This is a neat feature where you can look for a particular value. And then we'll type that in here, Marshall 1998. I'll say find next. It found it. And look at that. The winning percentage is about 91%. So our XLOOKUP function absolutely worked. Great to see that. Let me go back to our post-season games, and I'm going to drag that formula all the way down. Look at that. Great. Looks good. Now let's do the same thing, but from the away team's perspective. Since we're going to do roughly the same thing, it's a great copy-paste use case. I'll simply start by highlighting the two home team season, home team regular season winning percentage columns, highlighting the first two rows. The first row for the headers and the second row, because it's the first row that has a formula in it. Could do Control C, go to the first cell where we want to start the copying, Control V, so our paste shortcut. Now this is an example where we copied and pasted these cells with formulas, and it threw things off. See, it says Toledo-36133. So the easiest way to see what happened here is to double click into the Excel. Now we see that great highlighting with colors that Excel provides to us. Hey, we're starting, it turns out that the cell M is exactly 2 cells away to the right from cell K, and so it moved it from the home team to the away team, which is exactly what we want for this away team season variable. But we need to move this shifted cell back to the season column like this. And now that looks a lot better. For let's update the title here, the away team season variable, and we'll go ahead and update the title over here. Simply say the away team regular winning percentage. Okay, well this column M, the away team season column, looks great. Let's go to the bottom right, double click on that, let it scroll on down. Very good. Away team regular season winning percentage, similar to what we did for the away team season column. Let's double click and cell into, see where things are looking. Well, it is looking at the preceding column, the away team season column, to get that value that we want to look up. And notice that it is shifted again. The cells, the columns that are being referenced in the winning by team season worksheet. So that's the same worksheet that we were using for the home team's regular season winning percentage, and we can use it. It just has A teams in a particular season's winning percentage. We can use this for away teams and home teams. So we can still use it, but we still want to be referencing A as the lookup column and B as the returning value column. And so let's go into the formula here. We can also edit it up here. Let's change this from C, just rolled over 2 to the right when we copied it, change that back to A, and change the return column from column D to column B like it was before. And that'll return for Toledo in 1998, 63%. Let's just do a quick check. I'm going to do Control C to copy that value, Toledo-1998. Go to the winning percentage by team season tab, Control F to bring up the find and replace menu, Control V to paste Toledo-1998. Let's search for that, click find next. There it is, 63.64%, and that's exactly what was returned. We've done our validation. It looks great. Only thing left to do for this column is double click on the bottom right corner, and it applies that formula to all the rows. Looks absolutely great. Now for our analysis, we don't just want to look at the individual percentages. What we'd like to understand is, okay, there's 2 teams that are playing each other. A lot of times in a postseason game, they're both teams that did really, really well, and so both winning percentages would naturally be high, or maybe some that barely made it into the postseason bowl games, and their winning percentages would both be maybe moderate, maybe close to 50 or 60%. We want to understand the difference between the 2 teams that are playing. How large is that difference? So let's go ahead and create a column that calculates that. We'll call this difference in, and we'll use RS for regular season again, regular season winning percentage. And that, now we need to figure out what team's perspective we're going to calculate that based on. Remember, our home team won variable is calculated based on whether the home team won. From the home team's perspective, is it a 1 or is it a 0? Is it a win or a loss? So we should do the same thing here. So we'll start with it being the home team's regular season winning percentage, and subtract from that the away team's regular season winning percentage. In this case, the home team's regular season winning percentage was 27% higher, 27 raw percentage points higher than the away team's regular season winning percentage. And so it's positive. And we'll double click the bottom right corner here to scroll that down. Here's a case where the away team's winning percentage was higher than the home team's winning percentage. And so it's a negative from the home team's perspective. All right, well, this is good. Now, what we'd potentially do next is we need to do some kind of aggregation and say, in general, when this difference in regular season winning percentage is high or low, how does that impact the rate of the home team winning? But if we were to simply group by this column, it's a very granular column. 27.27 is going to be seen as different than, say, 28% if we had one like that. Those would be seen as distinct values, no aggregation there. We need to do some grouping so that we have more than just one or two games included in a specific raw percentage. We cannot do our analysis this granular of a level. And so we'll create a probably same category, same name, but let's call it category. We're gonna do some grouping here, and we'll do that grouping with an if statement. I'm going to start similar to our other functions with equals, and then we're using the if function. This is the same function we used to define whether the home team won or not. But this time, it's going to be a little bit more complex. We're going to do what's called nesting. So it starts out with a regular if function, and we'll say if this difference in regular season winning percentage is greater than, let's say, 0.25, which would be 25%. Even though this shows as 27.27 behind the scenes, if we were to convert this to a decimal format, for instance, we'd see that actually represents 0.2727. So greater than 0.25, if that's true, we're going to say it's a greater than 25% difference in winning percentage. Okay, so in this case, instead of returning a number like 1 or 0 like we did for the home team won variable, we're going to actually return a text label. And then that would be the argument. So remember how an if statement works. There's a test. Is this cell O2 greater than 0.25? And if it is, we'll return a text value in this case, because it's in quotes, greater than 25% difference in winning percentage. And let's say, we could do, if that's not the case, well, then it's less than 25% difference in winning percentage. But in this case, I'd like to have, what that would do is just return two possible values. I'd like to maybe group it by 3 or 4 different categories so we can kind of see if there's a consistent trend as we go higher or lower in the difference in regular season winning percentage. Does that make the home team more or less likely to win? And is there a consistent trend there? And so I'd like to have some more potential categories. In order to do that, we're going to nest if statements. What that looks like, we could have actually done that for the return true value, but in this case we say if this cell is greater than 0.25, return this value. If it's not true, rather than just return a specific value, we're going to ask you to execute another if statement. So we'll say if, we're nesting an if within an if this is now greater than 0, that's the test, and if that's true, then return maybe 0 to 25% difference in winning percentage. Why 0 to 25%? Well, obviously it has to be greater than 0, or else this condition wouldn't be true. But if it was greater than 0.25, it would have already returned this greater than 25% difference in winning percentage. So if it meets this criteria greater than 0, and it's going to return this value, it means it wasn't greater than 0.25, but it was greater than 0. If that's the case, that means it's 0 to 25% difference in winning percentage. And we're going to do a nesting again. Do another comma, and for the value if false argument, for this nested if statement, we're going to nest another if statement. If, and we'll go O2 here, if this is now greater than, let's say, negative 0.25, then we will give it a category of negative 25% to 0% difference in winning percentage. Okay, I'll put a percentage after this. Now, for our last argument, we'll say anything that hasn't been found to be true in any of the criteria so far. It's not greater than 0.25, it's not greater than 0, it's not greater than negative 0.25, and in other words, it's less than negative 0.25. In that case, we'll give it a value of less than negative 25% difference in winning percentage. This would mean the away team's winning percentage was 25 percentage points, raw percentage points, or higher than the home team's regular season winning percentage if it falls in this less than negative 25% difference in winning percentage from the home team's perspective category. Now, there's quite a bit of nesting going on here. So watch what happens when I try to close off the if statement's function. I'll put a close parentheses there. Notice very briefly here, it highlighted the open parentheses to say you are closing off this particular if statement. I'm going to type another close parentheses, which closes off this if statement, and another close parentheses to close off this if statement, and that's the last one. So when I press enter, there we go. It looks good for this row. Yes, the difference in regular season winning percentage was greater than 25%. Now, what's going to happen when we ultimately group by this is it will naturally sort it in alphabetical order, and it may not be the right order. It might not be a consistent order where it has the greater than 25% first, and then the 0 to 25% after that, then the negative 25 to 0% after that. There's a few ways of handling that. One way could be to add a number or a letter in front of this. That's what we'll do in this case. I'll say something like A. I like to use letters A, close parentheses, and then I'll put this one B, close parentheses. This is just a very simple way to keep things sorted in the order that we want them to, since it's going to sort them by, eventually when we do a pivot table, it'll sort them in alphabetical order. Putting these letters before each value is going to keep them sorted in that way. So now it has an A in front of it. And let's double click in the bottom right corner to scroll down. All right, 0 to 25%. Yep, 15, 16% falls in there. All right, our negative 17% falls into the negative 20%, 5% to 0% category. Let's see. Oh, here's one that's negative 33%. And there's an example of column D. It looks good from a sanity check perspective. And this is great. We are ready to build a pivot table now. We're ready to do some aggregation. And again, in Excel, very popular way to do aggregation is to use a pivot table. Because right now, we're looking at 900 different rows. Now, we could go line by line. I wouldn't even call this an analysis approach. This would be anecdotal evidence. It would be to go through and say, did you know back when Marshall and Toledo played each other back in 1998, Marshall went into the game with a 91% regular season winning percentage. Toledo went into the game with a much lower 64% regular season winning percentage. And guess who won? It was Marshall, the home team. So the team that had the higher regular season winning percentage won the game. And therefore, when you have a higher regular season winning percentage, you're going to win the game. Right? And I guess, let's see, we have, here's another case where the home team Air Force had a higher winning percentage than BYU, and they won the game. And so all of these are anecdotes, right? Eventually we'll have something that disproves the theory, I would imagine. So yeah, here's a case where Texas A&M, home team, 83% regular season winning percentage. Well, Kansas State came in with 100%. So Kansas State had the highest regular season winning percentage between the two teams playing in this game, but the home team, Texas A&M, ended up winning. So that's an example that defies that theory. So what we need to do is not look at anecdotes, individual examples, but we've got about 900 examples here, and we want to see if our theory tends to be true in general. We know there's going to be exceptions. That's why the game is played. If we knew the outcome, they wouldn't need to play the game based purely on their regular season winning percentage, we want to understand if there's a general trend here. In order to do that, we need to do some aggregation across games. Now, we're going to do another pivot table here. I'm going to highlight, go to the top left corner to highlight the whole table, and then I'll go back to the Insert tab, Pivot Table, say OK. Great. And we're going to go to our rows again. We've got our starting table over here, our fields that we can choose from over here. We're going to scroll to the bottom. These are usually listed by default in the order that they were in the table. So the very last column that we created is at the bottom here. We want to drag that into the rows field. And there we go. We've got our 4 different values there. Now there's this blank here. We can actually exclude that blank by clicking the drop down or arrow, and we can exclude other values too, but I'll exclude those blank rows there. And notice it's sorted in this way because we included the A, B, C, and D for the order of our categories. Just a quick, simple way to do that. Now, what we're interested in is we'd like to understand what the winning percentage, the postseason winning percentage, was for each of these categories. And we have this variable, home team won, that tells us it's a 1 if the home team won that game, a 0 if not. Let's bring it into our table by putting it in the values space here. Again, does a sum by default. We want to change that to an average, which because it's a 1-0 variable, is going to represent the percentage of the time that the home team won. It's going to be interesting. There it is. All right, let's do some formatting. Left click on column B, right click, format cells, percentage. We'll leave 2 decimals. Look at that. Fascinating. Fascinating. When the winning team, or when the home team had a regular season winning percentage that was 25% or more higher than the away team, that home team won 76% of the time. Wow, that's pretty high compared to what you'd expect for a typical postseason game, especially. And then if the home team's winning percentage in the regular season was 0 to 25% in raw terms higher than the away team, the home team winning percentage was 64%, which is still somewhat high. It makes sense that that wouldn't be quite as high as the greater than 25% difference because it's not as large of a regular season difference. So it kind of goes along with our theory. And then if you look at the cases where the home team's regular season winning percentage was between 25% to 0% lower than the away team's winning percentage, the home team still won more often than the away team. The home team won 53% of the time, even though they had a worse regular season winning percentage than the away team. That's kind of interesting. Maybe it speaks to their home team advantage. Maybe that home team advantage was driven by not their raw record, but perhaps there was some strength of schedule built into that as well. And it's true enough, they ended up winning a little bit more than average. And this is a very small difference between the two. I doubt it would be statistically significant, but we could do probably a difference in proportion test to assess that if we wanted to. But if the home team's regular season winning percentage was less than 25% of what the away team's was, the home team still wins 52.5% of those games. Fascinating. So in every category, the home team wins more, but you can see if we found that the home team, their winning percentage was more than 25% of the away team, they have an extremely high opportunity to win. Very interesting. Now, anytime you look at a percentage like this, it's also good to factor in how much volume there are of those circumstances. How often do 2 teams actually play each other and their regular season winning percentage was more than 25% different? Usually in the postseason you'd think similar teams are being paired up. So maybe this is driven by a low volume situation. Let's assess that. So one way we can do that, we just need to count any field that would never be null. So I think season's probably a good one to bring in here. It's going to sum the season by default, which is interesting. Let's go back to our tab. Oh, season is, season's a year, so that doesn't really have any intuitive meaning. Let's go to the drop down next to sum of season, and value field settings, we're going to change that to a count. There we go, and we should format this not as a percent, but format it as a number. So we'll get rid of the decimals. Okay, good. We can see that this 76% is actually only driven by 29 examples. Only 29 examples since 1998 in the postseason, two teams playing each other, and their difference in winning percentage was more than 25% different. And that makes sense. Again, that's probably how postseason games get created, is they're trying to match teams with a similar performance in the regular season. Similarly, on the other side of things, it's very rare that that scenario comes up. Plenty of cases here. So when I look at this, I'm a little concerned that it's interesting that these really extreme cases, there's a really high percentage chance of winning, but that's not a lot of volume. And so what I might do, just lots of different approaches here, but what I might do is go back to the postseason games tab, and I might update these categories to do something like maybe we lower that threshold so we have a few more games included in our top category. So if I lower this to say, well, let me know if the difference is more than 20%, and then I'll reduce this down to greater than 20%, and that would mean that this represents 0 to 20% now, and we'll make this, we'll say if it's greater than negative 0.20 as well, which will change this to a negative 20 to 0%, and this would be less than negative 20%. Alright, now we need to make sure we apply that to everything by now double clicking in the bottom right corner. Expand this. Okay, all cells are updated. Now if I go back here, nothing changed in the pivot table. This is important. You need to refresh your pivot table afterwards. So you can just simply right click anywhere in the pivot table, click refresh. I think it's because I have this filter here. Yep, before it was filtered on just those values. Let's do select all, and we'll deselect the blank again. Okay. Very good. Well, our volume didn't really change too much, but we have a little bit more volume in our extreme cases here. So we have 54 in our greater than 20, 49 in our less than 20, and you can see that that brought down the home team's winning percentage here, and it actually brought down, I believe, the negative 20. So maybe some of that 52%, it was just below the category above. The less than 25% category was negative 25% category was right in line with the negative 25% to 0% category, 53 versus 52. Well, now it's got a little bit more volume included in the categories. It's it's still somewhat low volume. I'm just gonna go and do this one more time. Let's change this to a 15% threshold instead of the 20%. 0.15, 15, and then negative 0.15, negative 15%. There we go. Make sure you double click the lower right corner, update that, and nothing changed until we right click on the pivot table, click refresh. Okay. Oh, I did not update this. There we go. Drag that down again. Right click, refresh again. We run into the same issue we did before. Just select all and then deselect the blank. Okay, this is good. All right, we've got a lot more volume actually. So the top category, if the home team's winning percentage was 15 percentage points or higher than the away team's percentage, we have 128 games where that was the case. And the home team's winning percentage was 67%. Well, this is interesting. Oh, actually, just discovered our ranking here is kind of odd. It did not rank. It put D right below A. That, yeah, we don't want that. So how can we sort a pivot table? Well, we can click here, and I believe we can just say sort A to Z. There we go. For some reason it got sorted a little differently there. And now we have A, B, C, and D. Okay, 128 in our top category where the home team winning percentage was 15% or higher than the away team's regular season winning percentage. Goes from 67% to 63% if the home team's winning percentage was 0 to 15% higher. Then it goes to 54% from there if the home team's winning percentage was slightly lower, between 0 and 15 percentage points lower than the away team's winning percentage. That's based on a lot of volume. And then now in our lowest category, we have 100 games where the home team's regular season winning percentage was actually more than 15 percentage points less than the away team's winning percentage. And sure enough, in that case, the home team winning percentage is actually just under 50%. When I look at this, I see a consistent trend. It's consistently the case that at least for these four categories, the higher the home team's winning percentage was relative to the away team, the higher the likelihood that the home team won that postseason game. And it's easy to see that based on this chart. If you like this video, I hope you'll consider liking it formally. And if you'd like to see more analytics, data science, and leadership training videos, please consider subscribing to the channel. Finally, if you have any questions on what we discussed today, please leave a comment and I'll try to respond to it as soon as possible. Thanks again for watching, and I'll see you in the next video.